Okay, so good afternoon, everyone. My name is Segun. So I am a senior software engineer at Moniepoint. I primarily work with Java, Spring, MySQL. So some of the things I'm talking about are kind of based on the experiences I had. I do this in all places, but some good cases for this are like when you have like jobs, because many of these jobs, they fetch a lot, you can fetch a lot of data at once and like write a lot of data into the DB at once. So I just like took an example of like just a simple query just to illustrate this problem. As you can see here, in the first query, I'm inserting like 5 records. In the other ones, I'm inserting records one by one. And the time it took to insert 5 records is the same time it took to insert 1 record. And even in some cases, like inserting 1 record was even slower because of obviously other factors. But like the general idea here is that if you can find a way, or if you look at your code and you find ways whereby the operations you're doing in your database, you can aggregate them. Like this is not just limited to just like insert. It also really ties back to like what we're showing. Let's take an example. Let's say like you have a provider that notifies you for transactions, like our modified virtual accounts. When you receive payments, we notify you for transactions. So one way to solve that problem, like to handle that, is like you have like your endpoint that like receives notification, then you process the notification and do all the things you need to do. So this process here of processing it means like is like the process I'm abstracting here is the process of you doing whatever like logic you need to do to give value to your customer. Now, like in one sense, this could actually be faster because there's no other shenanigans done. Like you're just doing what you need to do. But another approach you could take would be that instead of processing those notifications, you log them. When you log them, then you can now come and have a job that now goes and fetches the data and processes it. One thing you can also see that you gain from here is like you can actually now also take advantage of some of the things we talked about earlier of batching these operations and doing them in batches, therefore gaining better performance. But there's still additional benefits you get from doing this, which we'll talk about in the next topic. So so this is the next topic. So like based on what we talked about of batching things, it gives you the advantage, it creates the opportunity for you to take advantage of multiple threads. And one of the things about multi-threading is that you really want your operations that are really independent of each other, that you can operate on in parallel and like not have like conflicts. And when you read things like from the DB, like in this case of processing transactions now, you could like read them all in memory, like in a batch in memory. They really have multiple threads just execute on those individual transactions because for the most part, they are really just independent like units of work and they don't crisscross on each other. You could also use like a thread pool to like just handle that, and that just takes care of things for you. Then one other thing you should also take note of, which is like at least from experience, when you try to like flood your DB with a lot of requests to like save things, you could encounter issues. And from the experience I have, sometimes those issues occur from like your thread pool size. And if you're experiencing like, it starts to fail because the DB is just getting overwhelmed, it might be because of your thread pool size. So consider like exploring the option of increasing the thread pool size or other parameters related to the DB and the amount of concurrent connections it can handle. Because one thing I've come to realize is that our database can really handle a lot more than we give to it. So it's important that we try to maximize the resources we have. So like building on the example of the batching, so by virtue of the fact that we're batching a request, it creates an opportunity whereby all we really just need to now change in this case here is instead of just processing the notification on like our like main thread, we could just like submit it to like a thread pool, which in Java is like an executor service. So you just submit it there and like you just gain like great speed advantage because all these things just operate independently and they get processed. In conclusion, we've learned how to aggregate data on the database level. how batching operations makes it faster than runs faster than individual calls, how we can build systems that can recover from failure, and how we can take advantage of our multi-core servers. So thank you for listening. Do we have any questions?
Questions, comments, observations, grammar. Any questions?
Yeah, I'm not sure. So, might sound weird, but yeah, so in reality, there's nothing you are like sacrificing when you batch. I mean, aren't you putting more work on the DB?
Yes, you are. But like I said, the DB can actually handle more than we think it can. And if eventually you put more work on the DB, I think one thing I feel like one thing developers try to do is try to help the DB. The DB is highly optimized and efficient for doing a lot of operations, more than what you are giving it to do. So I feel like if your problem is like you are doing too much on your DB, then maybe scale up your DB and give it more resources, or that's a different problem on its own, But I feel you should get there first, then talk about optimizing your database service. But everything is really all about understanding the trade-offs you're making, And more often than not, I've had my application server restart because it was running out of memory or something. But my DB, I know it restarts too, but I don't think I've ever seen it or experienced the problem of it restarting. So it's clearly more reliable and efficient than the application server. So, any other question?
Which has yeah, I have a question. So my question is about that issue you experienced with that temporary table. Can you please shed more light on it?
So the problem is that, like I said, if you in Spring, if you want to update something, like update a table, and that table has a join on it, the ORM will try to optimize that process. So the problem is that the fastest or the most efficient update query is update where ID is in X or equals to X. But if you have an update query that has a join, that'll be less efficient.
Yeah.
So what it tries to do is that it will now, all the conditions for selecting the ID is going to create it and insert those IDs of your join conditions into a temporary table. Then in the update or delete, it's not going to do delete where ID is in the temporary table. So, but that was disabled on our production DB. And I don't even know how that was disabled because I keep trying to check, but I couldn't find out. But the point was, it was just not allowed on production. And I assumed for a good reason. So eventually, we realized that join itself was even erroneous. We should not have been joining on that thing. And we reworked it and just avoided that. Because ideally, you really should not be doing joins on, updates on joins and, stuff like that.
A follow-up question.
Yeah.
Not a follow-up, but another question, right? So, have you ever had an instance where you had to replace an ORM query with a custom SQL query?
Yes. This, that query I was showing, the first one, though, that one I showed is a custom generated one from ChatGPT because I didn't want to carry my work code to show you here, which I even realized during the talk that it was actually doing something not efficient because I think it was doing a join. Well, either ways, I had to what I ended up writing was like I said, I rewrote the query as a native query whereby everything just happened in place. So I selected everything into a subquery, then now did a join on that parent table to eventually get the I was computing the progress. I did a select to compute the progress and evaluate it into like a temporary table. Then now they join on that based on the ID to now update that value in like the primary table.
So you thought about temporary tables then twice now, and in my head I'm thinking about speed considerations.
Sorry. When I mean temporary table, like I don't mean temporary table. Like this is what I'm talking about. I'm not using temporary table. I mean like using like a subquery. Yeah, that's what I meant.
But is there like a trade-off with temporary tables?
Is it like
Like a speed trade-off, for example?
not that I know of, but like I said, it was not allowed on production, so I guess for good reason.
Sorry. So when you were explaining, best practice, like the example of when you get payment notification.
Yeah.
So the log routine there, like, is it also a database interaction or is something more asynchronous?
So like it can be a database interaction because you do need to store it in a persistent storage just in case server restarts. And it really should just be a simple like log and not start doing extra gymnastics. Just really log in all you receive from the provider. Therefore, you can now act upon it. Except maybe you want to use some other form of storage, like maybe like Kafka or something. But I feel like a database works fine for this because you want more guarantees.
Yeah. So follow up from that. So if the primary source of storage is a database, right? And I think you mentioned that one of your tips was that we should move
Aggregations.
Like batch updates away from the application server, right?
Wait, no. I didn't say move it from that.
Like use cron or something external to the application, right?
Yeah, like if it applies.
Yeah, applies.
Yeah.
But I wanted to ask, so how would that interaction be if you have another set of tooling to perform some application level update? Well, it's a database update though. So like currently your own use case, is the reliance heavy on like cron jobs outside the application?
This was really, there was just really one use case that really had this problem. And that was the place where we needed to update the progress of transactions. Like we needed to see the status of it in real time, in pseudo real time. So that was one case whereby like this really applied and was useful. But it would not, you can't want to call in providers and be sending it to the DB. That doesn't work. But whatever operations you really can offload, like I think this really just comes down to like really breaking your processes down. And if there are some that would benefit from being moved to the DB, you should. If not, just keep it in the application. Any other question?
Has Spring updated
Save all.
Hibernate? I'm tempted to Hibernate.
I don't know. At least. So, the unfortunate part there is, most companies, they don't update their libraries so often. So, at the very least, one we are actively using does not have save all updated. So, all right. So, thank you all.